Hello, this is Charlene. In this video, we are going to be doing compositions of functions. And we are given f of x is equal to x squared minus 3x plus 1. And we are also given g of x equal to 5x plus 4. And they want us to find f of g of x. So before we start that process, though, I just want to make sure that you understand that this notation right here is exactly the same thing. F of g of x can be written as f of g of x. So these two things are exactly the same. So if you see the different notation, it's not anything new. It's the same thing. Okay, so what are we going to do with this? F of g of x. F of g of x means that I'm going to take the g function and I'm going to put it inside of the f function. So I'm going to take this g function right here and I'm going to put it inside the f function. Everywhere there is an x, I am going to put 5x plus 4. Okay, so let's work on this. Okay, so x squared. X squared is going to become 5x plus 4 squared. So 5x plus 4 squared. Oops, it doesn't really look like a 2. It looks like a z. Okay, that's a little bit better. Okay, and then minus 3x is going to become minus 3 times the expression 5x plus 4. So minus 3 times 5x plus 4. And then we still have the plus 1 on the end. So plus 1. Okay, so the first thing we need to work on is squaring this expression right here. So we're going to do that over to the side just so we've got a little bit of room to work. So I got 5x plus 4 squared is equal to 5x plus 4 times 5x plus 4. Okay, so I'm going to distribute that 5 to both of these terms, and then I will distribute the 4 to both of these terms. Sometimes people refer to it as foiling. So there we go. 5x times 5x is 25x squared. 5x times 4 is 20x. 4 times 5x is another 20x. And 4 times 4 is 16. And then we just combine our like terms, and we end up with 25x squared plus 40x plus 16. So that is what I'm going to go ahead and move over here. Okay, so that's equal to that. And then I'm going to go ahead and distribute this negative 3 into this parentheses in order to eliminate the parentheses. So it's going to be negative 3 times 5x is negative 15x. And then I'm going to have negative 3 times the 4, which is going to be negative 12. And then I've still got this plus 1 on the end. And I just continue using order of operations and combining like terms. So I've got 25x squared. I have no more x squared terms, so I end up with just 25x squared at the beginning. And then I have a 40x and a negative 15x. Well, 40 minus 15 is going to be 25x. So it's going to be plus 25x. So I just took care of these two terms. And then I'm going to have plus 16 minus 12 plus 1. So 16 minus 12 is going to be 4, plus 1 is going to be plus 5. So we have just composed a new function. I had quadratic function there, I had a linear function there, and when I compose those and do f of g of x, I come up with a new quadratic function. This is the new composition of function, a function that comes from the f function and the g function. And I can also, I need to keep that same name, f of g of x. That is the new function that we have created. Okay. Okay, our next problem says that we're going to do g of f of x. We have the same f function, the same g function, but I do need to point out one thing before we go forward. In the previous problem, we had f of g of x, and this one we have g of f of x, but these two functions are not the same. They are not equal, they are not congruent, they are not equivalent. So just make sure that you understand that you cannot just flip them back and forth and get the same answer. You will get two different new functions. Okay, so let's go ahead and move that out of the way and get started. Okay, so this one says that we're going to put the f function inside the g function. So I'm going to take this f function and I'm going to put it inside the g function. Okay, so it's going to end up being 5 times my quadratic of x squared minus 3x, oops, 3x plus 1. And then I have a plus 4 on the end, so plus 4. Okay, so I am going to distribute the 5 into the parentheses in order to eliminate the parentheses. So I end up with 5x squared. 5 times negative 3x is going to be negative 15x. And 5 times a 1 is plus 5. And then I still have plus 4 on the end. And my final step is simply to combine the like terms, which I have a 5 and a 4 on the end that are like terms. So my final composition is going to be 5x squared minus 15x plus 9. So that means that g of f of x is going to be equal to 5x squared minus 15x plus 9. Okay, our next one says we're going to do g of x. So that means I'm going to take the g function and I'm going to put the g function in the g function. Yeah, I'm going to take the g function and put it inside the g function. Okay, so that means I'm going to do 5. And then where the x is, I'm going to put the entire function, 5x plus 4. And then it is plus 4. And then I'm going to distribute that 5 into the parentheses in order to eliminate the parentheses. So 25x plus 20 plus 4. So my final function, g of x, is equal to 25x plus 24. Okay, so if I have a linear function and I do a linear function of a linear function, it is still going to give me a linear function. It's still a line down here. Interesting, isn't it? Okay. Okay, for this next one, we have two new functions. H of x is equal to 5x squared minus 1, and k of x is equal to square root of 5x plus 5. And it says that we're going to take the k function and we are going to put it inside the h function. So I'm going to take this k function and I'm going to put it inside the h function. Okay, so it's going to be 5, and where the x is, I'll put this entire expression. So it's square root of 5x plus 15, or plus 5, and then that's going to be squared, and then minus 1. Okay, so we need to understand or remember that a square root and a square will cancel each other out. So that means that I end up with 5 times 5x plus 5 minus 1. Then I'm going to distribute that 5 into the parentheses in order to eliminate the parentheses. So 5 times 5x is 25x, and 5 times 5 is 25. And I still have a negative 1 or minus 1 out here. So my final h of k of x function is equal to 25x plus 25 minus 1, which is plus 24. So my new composition is 25x plus 24. So that was interesting because I started out with a quadratic, and this is a square root function, and I ended up with a linear function. That is the correct answer. The composition of h of k of x, 25x plus 24. Our next problem says k of h of x. So that means I'm going to take the h function, I'm going to put it inside the k function. So here is the h function, and I'm going to put it inside the k function. Okay. So I've got square root of 5, and then inside this x is going to go the entire quadratic 5x squared minus 1. So 5x squared minus 1, and then plus 5. So plus 5. So now, in order to start simplifying it, I need to distribute this 5 into the parentheses. So I've got square root 5 times 5x squared is going to be 25x squared. And then 5 times a negative 1 is a negative 5. Okay, and then I've got a plus 5. Aha! Simplify. Negative 5 plus 5, these two are going to cancel each other out. So I end up with square root of 25x squared minus 5 plus 5 turns into 0, cancels itself out. Now, can I take the square root of a 25? Yes, I can. So my k of h of x function is going to be equal to 5. Can I take the square root of an x squared? Yes, I can. It's x. So my final new composition, k of h of x, is equal to 5x. Okay, for this function, we have p of x is equal to 3 over x minus 4, which is a rational function. And we also have q of x, which is equal to 2x minus 8. And it says that they want us to do q of p of x, which means that we are going to take the p function and put it inside the q function. So I'm going to take this p function and I'm going to put it inside the q function. So I'm going to put 2, and then my big old rational function is going to go in here, 3 over x minus 4. It's x minus 4. And then there's a minus 8. So now to simplify this, I'm going to distribute the 2 into the parentheses. So 2 times 3 is going to be equal to 6 over x minus 4, and then minus 8. And so that is really all we need to do. Q of p of x is equal to 6 over x minus 4 minus 8. So that is our new composition. Okay, our next one says q of p of 6. We still have the same functions, the p and q that we had in the previous problem, and we've already created the new composition based on just x. So let's go ahead and pull that down because we've already done most of the work here. We came up with q of p of x is equal to this function, except now we're going to add this component. We're going to plug 6 into it. We're going to substitute 6 into it. So that means where this x is, I'm now going to put a 6. So that means that the q of p of 6 is going to be 6 divided by 6 minus 4 minus 8, which is going to simplify to 6 over 6 minus 4 is 2 minus 8. And that is going to be equal to 6 divided by 2 is 3 minus 8. So my final answer is going to be a negative 5. So Q of P of 6 is equal to negative 5. Okay, our final problem for this video is R of x is equal to 3 over x plus 2, which is a rational function, and T of x is equal to 3x minus 2, and they want us to do R of T of x, which means they want us to take the T function and put it inside the R function. So I'm going to take the T function and I'm going to put it inside the R function. Okay, so that means I'm going to have 3 all over 3x minus 2 plus 2. Okay, so we just need to simplify this. So we're going to go ahead and do 3 divided by, and I got minus 2 plus 2, so that's going to go away. So then I'm going to end up with just 3x in the denominator. So that means that I'm going to have R of T of x is going to be equal to 1 over x, because these 3's will cancel and my 1 will come out of invisibility mode. So R of T of x is equal to 1 over x. This video has been brought to you by Connect the Dots Online Math Tutoring. Before you leave, click on the like button and the subscribe button, and have a wonderful day.